Hi, and welcome to Learn It Real Quick. I'm Kevin Eitel, Physician Assistant Student here at Jefferson University, and today, myself and some of my colleagues are going to be explaining acid-base disorders. But to begin, what is a normal pH? So, when we're talking about acid-base disorders, we're talking about body pH. Now, a normal pH is 7.35 to 7.45. And how do we get that? Well, we get an ABG. And on the ABG, you see your pH, and then you determine whether or not things are normal, or if you have an acid disorder or acidosis, which is anything below 7.35 in your pH, or a base disorder, which is anything that we would call alkalosis, anything that's higher than a pH of 7.45. So, to start by going down the line. So when we think about our acid disorders and our base disorders, it really gets broken down into four categories. You've got your metabolic acidosis, your respiratory acidosis, your metabolic alkalosis, and your respiratory alkalosis, or as we'll refer to them throughout this video as MAC, RAC, MAL, and RAL. So Kate is going to portray metabolic acidosis, or as we like to call it, MAC for short. Kate, go ahead and tell me what is the primary problem in metabolic acidosis?
So the primary problem in metabolic acidosis is the fact that your kidneys are not making enough bicarb, which is the base, so because of that you become acidotic.
Correct. So in this case, fortunately, all of our members today have two hands. So we've got a left and a right hand. In today's example, our left hand is going to represent our lungs or our pulmonary function, and our right hand is going to represent our renal or our kidney function. So in metabolic acidosis, Kate has said that there is a problem with our renal system. We're producing too little bicarb. So Kate's right hand is going to be low. It's going to be low. Too little bicarb is being produced. Now, how do we fix that? We fix that by increasing our respiration. So Kate's pulmonary function is going to be high. It's going to be raised up nice and high. So that's what you see in metabolic acidosis. Kate, what are some examples of metabolic acidosis? What are some conditions that we would see?
So Kevin, before I even tell you that, I just wanted to tell the viewers that there's something called an anion gap, and that is what you are supposed to calculate in order to figure out your potential cause of metabolic acidosis.
Wow.
So once you figure out what your anion gap is, then you can actually pick out the disorder that is affecting you. But some examples of disorders that could cause this are diabetic ketoacidosis, kidney failure, shock.
Those are all great examples, Kate. What an excellent job you did. Thank you. So now I've got Shane Wilkinson. Today Shane's going to be representing respiratory acidosis, or RAC as we're going to refer to it. In respiratory acidosis, your pulmonary function is going to be low. You're going to be retaining CO2. How does your body correct that? Well, you're going to have you're going to be retaining bicarb because you've got acidosis, so you want to be hanging on to that bicarb to buffer that out. Shane, what are some conditions that we would see respiratory acidosis in?
Anything that would depress your respiratory rate or inhibit your breathing, so you'd have COPD, pneumonia, or ever more common today, opioid overdose.
And so since Shane's got a right hand and a left hand, and Shane's pulmonary function is going to be low, so his lung function is going to be low, so his left hand is going to be low, right? Whereas his renal function is going to be high. He's been trying to buffer out that excess CO2. So respiratory acidosis, you've got a low left hand and a high right hand. So Kate, our metabolic acidosis, is going to have a low renal function with a high pulmonary function. And with our respiratory acidosis, we've got a high renal function and a low pulmonary function, or the letter A, if you want to think about it that way. So when you think acidosis, think of the letter A. So now we're moving on to our base disorders, or alkalosis. We're going to start with Kelly. Kelly is going to be metabolic alkalosis, or again, MAL. In MAL, Kelly is going to have an elevated renal function, so she's going to have a high bicarb. So Kelly's right hand is going to be high. Now, in order to compensate for that, she's going to be holding on to CO2, so she's going to have a low pulmonary function. Her left hand is going to be low. Kel, what are some conditions we can see metabolic alkalosis in?
So you can see metabolic alkalosis if someone's vomiting, or if they're on diuretics, or if they overdose on sodium bicarb, like in a hospital setting.
Very good. So there's your your metabolic alkalosis. All right, finishing up, we've got Shar. Shar is going to be portraying respiratory alkalosis, or RAL, as we'll be calling her. So in respiratory alkalosis, your pulmonary function is too high. You are blowing off too much CO2. Because you're blowing off so much CO2, your body becomes basic. How do you correct that? Well, your kidneys are going to start dumping off that bicarb. They want to get rid of that bicarb. The system's way too basic. Shar, what are some conditions that we would see respiratory alkalosis in?
Well, we would see respiratory alkalosis in conditions such as anxiety, increased ventilation, and of course, we gotta get after it with the PE. So everybody at home, dyspnea on exertion with tachycardia, get after it.
Very good. So Shar, if you would be so kind, if you've got high pulmonary function, let's get that left hand nice and high. Very good. And we have low renal function, so we're going to keep that right hand nice and low. So when you think of alkalosis, I want you to think of the letter V. Whereas in metabolic alkalosis, you would have high renal function with low pulmonary function, as opposed to respiratory alkalosis, where you would have low renal function with high pulmonary function. So think of the letter V when you think of respiratory, or when you think of alkalosis. So to review, let's start with our acidosis. Let's start with our metabolic acidosis, or our MAC. In our metabolic acidosis, we're going to have low renal function with high pulmonary function, as opposed to our respiratory acidosis, where we're going to have high renal function with low pulmonary function. Moving on to our alkalosis. We're going to start with our metabolic alkalosis, in which we're going to have a high renal function with a low pulmonary function, as opposed to our respiratory alkalosis, where we're going to have a low renal function with a high pulmonary function. Hopefully you learned a little bit about acid-base disorders from this video. Please join us next time for Learn It Real Quick when we talk about identifying cephalization and curly V lines on a chest x-ray. Thank you.